I'm Megan Sawyer.
I'm Geni.
I'm Hannah.
This is the claw. This is the claw. Featuring our logo. Yeah. Yup. Okay.
So this is our design brief. Okay, our client name. Our project name is obviously the claw. Our client company is yourmom.com, and our target consumer is Target, and the children are the Target employees, and all three of us are the lead engineers. And the problem statement is the Target employees are incapable of lifting heavy objects by themselves, so they need a machine to do it for them. And our criteria and constraints are: the weight must be lifted at least 12 inches, the weight must be lifted in less than 30 seconds, it must cost less than $3 million, it must have a minimum AMA of 3, it must include at least 3 different simple machines, the applied effort force may only be provided by one simple human input, and it must have a way to measure the force needed to be completed within 2 weeks.
Okay, so these were our design options, brainstorming, I guess. This is the block and tackle system that we were trying to think out, but did not, decided against it. So basically, we attach a crank lever to this one. I realize now that this is very much not a compound gear, but it's fine. To a wheel and axle, and then that would just turn and start moving strings on this thing to move it up. And then the design we did go with was a movable pulley system with just 2 pulleys. The string attached to this one, attaching onto a spool sort of thing. That was the axle part on the wheel and axle. And then a chain sprocket system attached to the effort force gear with an effort force inputted by a crank lever.
Okay, for our design matrix, we did the pulley and then the compound gears and then a wheel and axle. We ended, I think the labeling on one of these is supposed to be different, but anyway. We did not end up going with the wheel and axle, so I'm pretty sure the labeling on there is supposed to be different because we did the sprockets that were like chained together and then the pulley on there too. And we also added easy to use, so like how easy
Here is our...
I don't watch this.
Okay.
I can't really do this right.
Hold on. Here's our video.
Should put sound.
No.
Okay.
I didn't even realize it was like reversed. Oh my god. Basically, this is just a close-up of the simple machines that we used. So this part here is the wheel and axle, and then this is our crank lever that we would put our effort force in, and this is the pulley that's attached to the weight at the bottom.
I like that, by the way. Nice close-ups of your individual little sections.
These are our calculations. The AMA for the chain and sprocket system is 1.3, or the gear ratio thing. But the AMA for the overall compound machine is 12.25. And the AMA of the pulley is 2.
Because there's 2 strings.
Yep, 2 supporting strands for the weight.
Yeah. And then the chain sprocket, the arm ended up being 2 once we did the teeth. And then the overall IMA after you multiplied all of them was 5.2. Our efficiency was quite the number. It's 236%. Not really sure how we got to that, but you know, we'll just act like it makes sense. So we just built a really good machine.
So
It's
you're
probably around 23%.
Yeah.
36.
Yeah, it's
so your AMA was 9.81 over 0.8.
12.25 divided by 5.2 is like over.
Yeah, I know. I'm
2.
just trying to figure out how we got such a big number for our AMA compared to our
we
IMA.
just built a really good.
So
Yeah,
you
we're
had
just
24
too
over 18. That was 1.3.
Yeah.
Pulley was 2.
Yeah.
It has to be hanging.
And Shane's sprocket had 24 teeth over 12 teeth. So that was also 2. 2 times 2, 4 times 1.3.
5.2.
Yeah.
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 I'm
Oh,
just really good at this.
you forgot one.
What?
The handle,
Oh shoot.
right?
So that's what messed
The
up.
handle's really huge.
Yeah.
And then that's a wheel and axle there. So the handle circumference over that circumference of that sprocket there in the middle
Yeah.
would be a lot more. That'd be a, I don't know what it looked like, almost 7 times greater than that. So that'd be like multiplying your IMA, which was what, 5.2, like times 7 or something.
Oh.
So it'd be like 12.25, like over 35 or 36.
Okay. That makes a little bit.
So
Yep.
it's probably like 33% efficient or something.
And then it costed $1,258,000 to make.
All right.
Yep.
Do a demonstration here.
Yeah. The crank on the backside does.
Yeah, we're kind of gonna need to like turn it like this. Yeah.
This is like
I'll,
the way it's gonna function.
I will go around here.
Perfect. Get all the angles on there.
Oh, yeah.
Now, if this doesn't work the first time, we're really sorry, but
This is just gonna be
it just might take
embarrassing.
a few tries.
All right, let's see what we got.
Okay, ready?
And the weight stuff in this one. Okay. Just go for it.
It just spins a lot for some
That's
reason.
just what happens.
Yeah, we're not really sure why, but.
Oh,
Okay.
almost.
It's gonna be
You almost
fine.
had it.
Oh no,
Is
this
it not doing anything?
Hold
at all?
on. There we go. Now go again. Hey, we're
There
still
you
at
go.
30 seconds. We're still
Yep.
at 30 seconds.
It's
There you
fine.
go. That'll
great.
work. That'll work. All right. Nice job.